Today we will discuss about hashing in data structure. So before going to see what hashing is all about, we have seen index page in your notebook, right? So what is the use of index page?
To identify the contents and
the content easily.
So you can, if you want to insert a new page number, so for example, let us take your observation as example. You would have 10 experiments written in your observation note. So this index page will contain the heading for all the experiments. So if I want to open experiment number 5, so with reference to the page number which is present in your index, you can open that experiment number 5. Similarly, if I want to add a new experiment to the observation, easily I can insert it into the with the help of index page. So this index page is used for easy insertion. And if you want to search, the search operation is also made easy with the help of index page. So this index is called as hash table in case of hashing. So this hash table, it contains of an array. This array contains key value pairs. So this key value is similar to the page number in your index page. This value is the data that I am going to store. For example, your experiment is your data in index page. Here value is the data that I am going to store. So in every index in an array contains key value pair. So key will be your index and value is the data that is given. So how we are going to store this data into this hash table is with the help of a function called as hash function. So this hash function can be predefined or it can be defined according to the number of data that we are going to store. So here the function is given as x modulo 10. So x is the data item that I am going to store. 10 is the maximum table size. So here we have chosen the table size as 10, which means the number of elements that will be stored in this table will be less than or equal to 10. So I cannot store elements more than 10. Let us take first value 4371. So here your x value is 4371. When I apply this hash function, what is the result? So 437 modulo 10 returns 1. So this modulo operator returns reminder. So 43 modulo 71 modulo 10 returns 1, which means this data is stored in the key 1. So here your key is 1 and your value is 4371. So in the index 1, 4371 is stored. Similarly, take the next data 1323. When I apply this function, the modulo operator returns a reminder 3. So your hash value is 3, which means in the third index the value is stored. Take the third value 6173. When I apply this function on this data, again the result is 3. But in this index 3 we already have a value. So which means two data values, so 1323 and 6173, these two data values are trying to map to the same index 3. So in this case collision occurs. So we call collision like when two data values map to the same index, that situation is called as collision. So to avoid this collision we have several strategies. So these strategies are broadly classified into two types. One is separate chaining and other one is open addressing. Under open addressing again we have three main classification. One is linear probing, second one is quadratic probing, and third one is double hashing. So who is going to explain separate chaining?
So I'm here to explain about separate chaining. In the separate chaining, we have to first see the index of the elements of the x. First we have 4371. It should be stored in we have to see the last index. It is 1. Then the element 4371 should be stored in first index, but in a chained form. Like this, we have to store the 4371 will be stored in this form. Okay. Next, you have to see the next element. There we contain 1323. The last digit is 3, so the element should be stored in third index. So it will be stored like this 1323. Next element is 6173. And then we have to see the index, it is value 3, then it should be stored in index value 3. But already there exists an element, so we have to map to the already element to it. So it occurs 6173 like this. And next we have to see the next element. It contains 4199. The last element is 9, so we have to index this value in the last 9th index. That means 4199. Next we have to see the next element is 4344. The last index is 4, so we have to insert in the fourth index of the list of the array. So it will be added like in the list format 4344. Then we have to see 9879. The last element is 9, so we have to add it in 9th index. In 9th index there already exists an element, so we have to map to the already existing element. So 9679 will be stored here. Next we have to see next element is 1989. There also last element is 9. So already 9th index contains 2 elements, so we have to insert a third element like this in a linked form. 1989. So this is how the separate chaining is displayed.
The next one is linear probing. In linear probing, here are the index value, and first let's take the first element 4371, and if we apply the function 4371 modulo 10, we get the remainder value as 1. So now place this number at the index value 4271 at the index value 1. Next take the number 1323. Here if we take modulo 10, the remainder will be 3, so place it in the index 1323. Next the number is 6173. If we apply the function, we will get the remainder as 3. So here the 3 is already exist. In third index there already exists the value 1323. So we cannot place 6173 here. So in linear probing we should add one value like 6173 plus 1, and the final value is 6174. Take modulo 10 for this, and the remainder will be 4. So now add this 6173 at the index 6173 at the index 4. For the next value 4199, if we apply the modulo 10, the remainder will be 9. So the 9th index is free, so let's add 4199 here, and the next value is 4344. If we apply the function, modulo 10 will be remainder 4, and the 4th index is already exist a value, so we want to increase this number by 1 and take the modulo 10. The remainder will be 5, and the 5th index is free, so we can add this value at 5th index. So the next value is 9679. If we take modulo 10, the remainder will be 9. In 9th index already a value is existing, so let's increment this number by 1. It will be 9680. Let's take modulo 10, and the remainder will be 0. At 0th index there is no element, so you can add this element in 9679. Next number is 1989. If we take modulo 10, the remainder will be 9. The 9th index already exists a number, so let's increment this number by 1. Now the modulo 10 gives the value 0, and in 0th index also there is a value, so we want to increment this number also by 1. It will be 1991 modulo 10. Now the remainder is 1. So at first index already a number is existing, so now we have to again increment it by 1. So it will be 1992. If we take modulo 10, it will be remainder 2. The second index is free, so let's add this number to the second index. So this is how linear probing works.
So we have seen two techniques. One is separate chaining and other one is linear probing. So here what is the drawback you could see with separate chaining?
And it is very difficult because in one address there are many keys.
See, as you have said, see for example